Hi, my name is Samantha Eason, and I'm a junior here at North Carolina State University. This past summer, I interned with NASA's Glenn Research Center, working on the integration of capillary forces and microgravity in STEM education. A little bit of background. Capillary action is the process of liquid naturally flowing towards narrower areas without assistance from outside forces. Capillary action is the dominant force in space due to the absence of the force of gravity. Seen here in the picture is a coffee cup that takes advantage of capillary action in order to allow the user to drink without the use of a straw or any sort of bagged item, which are commonly used on the International Space Station. While many experiments on board the ISS take advantage of capillary action, it can also be accomplished here on Earth using drop towers, which are vacuum chambers that briefly simulate the effects of microgravity. So the project that I primarily worked on was CELERY, which stands for Capillary Effects on Liquids Excretory Research Experiments. CELERY is an educational program at the GRC in which students in grades 8 to 12 can design their own experiments to test capillary action in GRC's drop tower. Students are instructed to design their experimental plate in a 2D software program, and GRC will then laser cut them out to be tested with. This video shows what occurs inside the drop tower. As you see, the fluid rises through the channels as it experiences the microgravity environment of space briefly. Students are given a video much like this after the completion of their experiment and are encouraged to rewatch it to draw their own conclusions from it. CELERY has been unoperational for the past few years, and researchers at the Glenn Research Center wanted to see it start back up again. However, this required the entire challenge undergoing a bit of an overhaul since the software program had changed from DraftSite to an updated version of LibreCAD. The first task that I had to do was convert the original template for the challenge for a format that worked with DraftSite to a format that worked with LibreCAD. The completed template is shown here on the screen. Other documents had to be converted for use by LibreCAD as well, including the tutorial, handbook, flyer, and various advertisement material, as well as the website. I started with the tutorial. This 80-page document guides students through a sample experiment and teaches them common LibreCAD tools, as well as, hopefully, inspires their creativity. After completion, I gave this tutorial to the high school interns for their review. After their feedback, I decided to add in a section that told Mac users how to download LibreCAD, as their instructions were a bit more confusing. I also created a handbook, which is a guiding document that explains the detailed elements about CELERY, such as rules, regulations, guidelines, and a section that detailed previous experiments. I also created various flyers and advertisement materials and compiled everything into one page on the NASA's Glenn Research Center website. Now, while CELERY is one way to combine capillary action and STEM education, the ISS Washing Machine Challenge is another way. I participated in this collegiate competition where the objective was to design a washing machine for the International Space Station, as astronauts do not currently have a way to wash their clothes. NASA provided the general layout for the washing machine as seen here, but my team was in charge of the portion circled in red, which is the initial hydration. My team designed a soaking roller system to wet the clothes in our washing machine. The concept that we designed was heavily inspired by old school wringer washing machines, but instead of wringing the water out of the clothes, our rollers introduced the water. After the rollers introduced the water, they were hooked onto that third and final roller in the back and wrapped around that pole in order to sit and soak for a while. So, in conclusion, STEM education is highly important and helps to inspire future generations to get involved with engineering and NASA research. By combining STEM education and fluid physics through programs like CELERY and the ISS Washing Machine, the Glenn Research Center is allowing high school students and beyond to utilize state-of-the-art equipment like drop towers that'll spark their curiosity and hopefully start them on a long career of scientific exploration. I want to say thank you to my mentors, especially Tyler Hatch and the rest of the OSTEM office, for their support and guidance this previous summer. And that concludes my presentation. Thank you so much for listening, and please feel free to reach out if you have any questions.